All right, so here are the notes for solving nonlinear systems. So I'll kind of read through this and go through it. So it says, in a nonlinear system, at least one of the equations is nonlinear. For instance, the nonlinear system shown has a quadratic and a linear equation. So the first one right here, y equals x squared plus 2x minus 4, we can tell that that's nonlinear. And the reason is because of this squared term, right? So that's going to be a parabola facing up. If it was negative, x squared would be facing down. And the second one isn't a linear because it's just x to the first power, so that's going to be a line like that. So our nonlinear and our linear, so it's a nonlinear system because of that quadratic function. All right, over here it says when the graphs of the equations in a system are a line and a parabola, the graphs can intersect in 0, 1, or 2 points. So the system can have 0, 1, or 2 solutions. So right here, we're just trying to see where do they intersect. So like right here, we can see the parabola and the line do not intersect. So this would be 0 solutions or no solution because they don't intersect. Here we can see that the parabola and the line intersect right here at the vertex. So that's going to be 1 solution. And for this last one here, we see the line and the parabola, they intersect at 2 points, which is going to be 2 solutions. Again, nonlinear system because we have a quadratic function and we have a line. So does not intersect, no solution. Touches at 1 point, that's 1 solution. Intersects twice, that's 2 solutions. All right. Now it says when the graphs of the equation in the system are a parabola that opens up and a parabola that opens down, the graphs can intersect in 0, 1, or 2 points. So the system can have 0, 1, or 2 solutions. So just like before, here we can see they don't intersect, so that's no solution or 0 solutions. Here we see they intersected their vertices, so that's going to be 1 solution. And then here they intersect twice, so that's going to be 2 solutions. Okay, so that's how you can tell graphically what they look like. All right, so example 1 says, solving a nonlinear system by graphing. Okay, so we're gonna graph these here and kind of see what they look like. Now, for me personally, I would do this in a calculator, but I'm gonna show you how to do this by hand here first. Let's start with the linear line. The linear line should be fairly easy to do. So we have a y-intercept at 0, -1. That's this point here. And we have a slope at -2, m equals 2, so -2 or 1. So we begin on the y-axis at -1. That's the y-intercept. Then our slope is down 2, right 1. So down 2, right 1. Backwards, up 2, left 1. And there's our line right there. All right, now let's go ahead and graph this right here, the quadratic function. So I can treat this as a vertex form. So y equals a x minus h squared plus k. So in this case here, we see that the a value is 1. We see that the h value, there is no h value, so we assume that to be 0, and the k value is -1. So therefore, my vertex is going to be 0, -1. And then from here, I'm going to use 1, 3, 5, 7 to graph it. I know my a value was 1, so I multiply each of these by 1. So 1 times 1 is 1, 3 times 1 is 3, 5 times 1 is 5, 7 times 1 is 7. Now I start from here, right 1. My first one is a positive 1, so we go up 1. From this point, we go right 1. My next number is positive 3, so up 3. And then positive 5, but that's where I go. So this one here, 1, then 1, 2, 3, and that's as far as I can go. So we make our graph. Oops. And we can see that it intersects actually in 2 points. So my solutions for this one would be they intersect right here at 0, -1. And the second one would be at -1, -2, 1, 2, 3. So -2, positive 3. Those would be my 2 solutions right there. Okay, now another way I would do this, and probably one of the way you're going to do it, is you're going to grab a graphing calculator. And what we're going to do is we're going to take these two equations here. We're going to press number 1. We're going to open up a new document. We're going to add a graph. If they say y equals great, I just get in the habit of deleting the equal sign, and I select number 6 relation. And then from here, I just type in the equation y equals x squared minus 1. All right, if you hit enter, just make sure you press tab to bring it up again. And then y equals, the second equation, negative 2x minus 1. And hit enter. All right, now once again, when this is in the way like these, I'm going to just click on it. Once it grabs it, I'm going to pull it away. There you go, let's pull that one away. Let's grab this blue one right here and move that out of the way as well. All right, so we have that there. Now we can see our graph, and the graph does match ours. They're the same graph. So to find the intersections, it's going to be menu 6, 4. All right, so we're going to do menu 6 and then 4 for intersection. All right, I'm going to do that first one here on the bottom. So I start at the right side of it. I click down. Once I scroll over it and the word intersection pops up, I'm going to click down again. Oh, so there it is right there. Just click down. And we see our first solution is 0, negative 1, which is one that we came up with as well. All right, now we're going to find the second one. We're going to do again menu 6, 4. This time I'm going to move it to the left side of the other intersection. So the other intersection is up there. So you click down and you slide it over until the gray area crosses it and says intersection, which it does right there. And we can see our second solution is at negative 2, positive 3, which is the second answer we came up with as well. Okay, so you can see that graphing in the calculator using menu 6, 4 is also a good method to use. Sometimes you do have to adjust the screen and move it around to make sure you can see the answer, but menu 6, 4 will help you get through these quick. Okay. Example 2 is, or sorry, example 1 right here, it says, solve the system by substitution. Okay, so for here, we've done substitution before. We're just going to take one and substitute to the other and solve. But this is a little bit different. Let me show you what I mean. So for this first one here, they both say y equals. So what I'm going to do is, I'm going to take 2x, and I'm going to substitute it into this y right here. And that's going to give me 2x equals x squared plus 4x. And obviously to solve this, we have to make it equal to 0. So I'm going to bring the 2x to the same side. So I'm going to subtract 2x from 4x. And that's going to give me x squared plus 2x is equal to 0. Since I have a squared term, I'm going to use my method of factoring. So the first thing is, it's a quadratic function. Is it in standard form? Set equal to 0? Yes. Is there a greatest common factor? Actually, there is, right? If you take a look, x squared and 2x are both divisible by x. And when we factor that out, x times x is x squared. And x times 2 is 2x. And now we actually have them both figured out. Now what we can do is set both of them equal to 0. So x equals 0 and x plus 2 equals 0. So for this one over here, we subtract 2 and we get x equals negative 2. Now this is where you have to actually be careful, because when you're solving a system of nonlinears, we've only actually done half of the work, right? We've got x is equal to 0 and x is equal to negative 2. Those are not my answers. Look at the previous two answers. You have to find x, and you also have to find y, okay? So right now we found x for both of them. We know there's going to be two intersections. Now we need to find the y value. So here's how it works. Okay, so I'm going to take x equals 0. And I'm going to take x equals negative 2. Then I'm going to pick one of these equations over here, and I'm going to substitute it in to find my y value. The easiest one appears to be y equals 2x. Okay, so for this one here, y equals 2 times x is 0. So y equals 2 times 0 is 0. So I have my ordered pair of 0 and 0. So there is my first solution. And for my second one, I'm going to plug negative 2 into the same equation. So y equals 2 times negative 2. So 2 times negative 2 is negative 4. So I have x is negative 2, y is negative 4, so negative 2, negative 4. All right. Now from here, I'm going to verify my answers, and just going to type it into the calculator. All right. So there's my calculator. So again, delete the equal sign, number 6 relation, and y equals 2x. This, if I press down, it goes to the next line. If I hit enter, I have to press tab. So y equals x squared plus 4x. Enter. Okay. Again, I see this is in the way, so I'm just trying to grab it and move it out of the way. Got that one. And I got that one. All right, and then here we're gonna do menu 6-4. So here, and move it to the left. So my first answer is 0, 0. Now I'm gonna go on this side, menu 6-4. I'm gonna slide it to the right. Intersection, and we have -2, -4. So 0, 0, and -2, -4, which are our two answers. Okay. The next example, same thing. We're gonna do substitution here. Make sure it's there. Okay, there we go. So let's take a look at this one. Okay, so for this one, again, they both say y equals, so I'm gonna take 3x and plug it in for this y. So we have 3x equals x squared minus x minus 5. We're gonna go ahead and subtract the 3x to the other side and make sure we take it away from the correct term. So we have x squared minus 4x minus 5 equals 0. This one, I'm gonna have to do the x method. I'm gonna try to factor it. If factoring doesn't work, then I have to do like the quadratic formula or completing the square. But let's go ahead and try the x method. So b is -4, a is 1, a times c is -5. So my factors would be 5 and 1, and since it's -4, it's gonna be -5. So this factors to x minus 5 and x plus 1. We set each one equal to 0 when we solve. So this one we add the 5. So x equals 5. Here we subtract the 1. X equals -1. Now from here, just like in the previous one, now we're going to find our x and y values, right? We have our x, we need to find our y values. So x equals 5. This might be running out of ink. X equals -1. All right, and now we're just gonna plug it in. Again, the first one looks really nice. Y equals 3x. So the first one, y equals 3x, so y equals 3 times 5. 3 times 5 is 15, so we have 5 comma 15. That's my first solution. For the second one, y equals 3x, so y equals 3 times -1, so y equals -3. So -1, -3. And there's our solutions. Again, we're gonna verify it in the calculator. Let's see if we got these correct. All right, delete the equal sign, number 6, so y equals 3x. Y equals x squared minus x minus 5. All right, so for the first one, we can do menu 6-4. Click, and, oop, too far. Let's go right here. Right there. All right, so we have -1, -3, which is right there. Now, here's the interesting thing about this next one. The next one, we know the solution is somewhere up here. It's somewhere up here. Now, I know it's at 5 and 15, so if I look at the x-axis and I try to find where 5 is, there's 1. Let's actually just grab this out of the way here. Let's move that out of the way. Okay. So there is 1, 2, 3, 4, 5. So the intersection is happening here, but somewhere up here. I think if you do menu 6-4 from right here, and as long as the intersection happens between here, you can actually get it. So let's see if this works. There's 1, 2, 3. So we'll do it about right here. We're gonna slide over and see if the, oh, there's where the intersection popped up because I knew it was at 5, so it should have been somewhere around there. Click it. It'll actually transport me to it, so 515 is the correct answer. Again, if you want to see where it's at, you can always click and move it around like that if you want. You can click and drag, but if you kind of know where the answer is, because I assumed my answer was right, so I knew it was at 5 for x. When I did the intersection, I just put the left of 5 into the right of 5, and there was the answer. Okay. Now, if you happen to be at home and you don't have access to this calculator, you could probably always use a Desmos. So like an example here, so let me use Desmos real quick, see if I can get this to show up here. So like y equals 3x. All right, so there's our first one, hit enter, and we can do y equals x squared minus x minus 5. All right, and here we can see our first solution. We can just tap it right there, -1, -3. Now, obviously, this is a lot more user-friendly, but we won't be using Desmos on tests and stuff. But at home, you can do it just as well. So I'm going to slide over here. Here's the next one. And we have 515. So Desmos is a good alternative at home if you don't have the Inspire calculator to use. All right, let's go to the last ones here. So this one says solve systems on nonlinear by graphing two variables x and y. Okay, so this is pretty much what I've been doing. So just showing you how I was checking my answers. So this is the actual method to do it. So you open a new graph, you hit delete, and you select relation number 6, graph both functions, and then menu 6-4 to find the intersection. So these will be fairly quick to do. So let me show you how quick it is on my calculator here. So never save it. So number 2, add a graph. Delete the equal sign. Select number 6, relation. Now, it doesn't really matter the way it's written. You're going to type it in. So x squared equals 2y plus 10. If you hit enter, press tab, or you can just press the arrow down. Type in your next equation, 3x minus y equals 9. Okay, and here I'm going to kind of adjust my window just a little bit. I'm going to drag and move a little bit. There we go. All right, so the first one I can see is right there, menu 6-4. Slide it till it says word intersection. There it is. So my first answer is 4,3. For my next one, menu 6-4. Go to the left of the other solution. Move it to the right. There it is. Click down. And we have 2, -3. So 4, 3, 2, -3. All right, and it is that quick, right? And the next one, same thing. Open up a new graph, never save. Delete the equal sign, select number 6, relation. We type it in the way we see it. We don't try to adjust this one. Arrow down. All right. And hopefully we can see that these two are so far away, doesn't look like they're ever going to intersect. I'm just going to drag it a little bit so you can see. So they are pulling away from each other. So this one would be a no solution. All right. And now for the last one here, it says solve equations by graphing only x. To solve this equation, write a system of two equations, y equals f of x, y equals g of x. Graph the system of equations, y equals f of x, y equals g of x. The x value of each solution of the system is the solution of the equation f of x equals g of x. Okay, so a lot of terminology there, but it's actually very simple. So what you'll notice here is that you actually have two equations. Now there's an equal sign, but don't get confused. This is an equation. So I'm going to say y equals 3x squared plus 5x minus 1. This is also an equation. So y equals negative x squared plus 2x plus 1. Okay. So it's not any more difficult than that, right? So you're just separating them into two equations. Both of them are going to say y equals. So we're going to type it into our graphing calculator. Add a new graph. All right, so 3x squared plus 5x minus 1. Arrow down. Negative x squared plus 2x plus 1. Enter. And we can see it intersects twice, but there's all this stuff in the way, so let's just grab and move some of that out of the way. And this one's in the way too. So this one's a little bit different because as you see, it says solve the equations by graphing, but you're only looking for the x value here. So when we do menu 6.4, so this first one is going to be right here. Oop, too far. There we go. Let's wait till it says intersection. And there's our first one. So x equals 0.425. And for the next one, menu 6.4, we go to the other side. And we scroll it over. And there it is. X equals negative 1.18. All right, and those are the notes for solving nonlinear systems.